Hi, in this video we are not going to learn about any new concepts of Manim. Instead we are going to do a hands-on. What I'm planning to do is I am going to create a video using Manim which would illustrate the concepts of dynamic array. If you are familiar with coding, you must be knowing what dynamic array is. It is an array which has the ability to change its size once the capacity is full. So I will let you first go through the video and I'll try to explain what dynamic array is in brief. I think the video is a little over 1 minute long, and then we'll dive into the code. I'll play the video now. So initially, let's say that the capacity is 4 and we keep on adding elements, and we are also maintaining this number which points to the index of next available slot. So as an element gets inserted, this next available index gets incremented. But what happens now when the index is out of bound and we have to insert a new element? We need to resize. The resize operation requires us to create a new array of double the length and then insert the element that we were trying to insert. And then we can keep on inserting more elements without resizing till we hit the capacity again. For example, we can insert one more element, that is 7, but now we cannot insert 13 without resizing. So we'll again create an array which will be double in length, and then we'll copy the existing elements and then we can add the next element. So this is in a sense what dynamic array is. And I think so this is the video, and now we'll have a look at the Manim code which I used to generate this. Coming to the coding part, this is all the code that was used to generate the video that we just saw. This is not the modular way to write the code. It can definitely be written in a better way, but we'll try to focus mainly on the Manim related things. So this is the class, and in the constructor I've made some variables so that I don't have to keep passing them from one function to another. Index is simply the index, the one that we saw, which will hold an integer value, which will tell us what is the next available slot. Pointer is the red triangle that we saw, which actually points to this index. So if we want to relate it to this actual video, this red triangle that you see, this is the M object which is stored in self.pointer. So it's a triangle of color red, and we are filling it with red color, opacity 1, and the scale is 0.2. So by default the size of triangle is large, so I've scaled it down to 0.2. Then this is the self.arr is the variable which is basically this array that you see. Now let's see what is the type of it and how it is created. So we are relying on this create method. If we step into this, it first takes what are the values that you want in your array, and the second parameter is how many blank slots you want after all your values. So if I pass an array of, let's say, 3 elements in place of values, and if I pass blank slots as 2, so the array that will be created will have a total of 5 blocks, 5 slots, and the first 3 will contain the values that we received in this values array, and the remaining 2 will be blank. So currently we created it by passing a blank array, as you can see here. So there are no values, and we specified 4 as the number of blank slots. So if we look at from very beginning, we'll see that an array has been created with no values and 4 blank slots. So let's have a look at how we are creating this array. It's a V group, and each of the square blocks that you see is again a V group, which are a part of this ARR group. So what I'm doing essentially is looping over the values that I have, and I'm creating a square for each value. I'm creating a square of orange color, and I'm again scaling it down to 0.4. I started without scaling, but then as I resized the array was going out of the view because of its size. So I've scaled it down to 0.4. You can choose whatever number you feel is appropriate for you. Then I am creating another M object of type text, and the value of the text will be the value that we are like the current value in iteration of the values array. And I am setting the color of the value itself to green. Yeah. And then I'll combine the square and the text to again form a V group, and then I will add this V group to the array. So array is a V group, and each element of this V group is again a V group, which contains two M objects. One is the square, the orange square, and the other one is the green numeric value that you see inside it. So this is the logic to create the starting blocks of the array with values in them, and then we are creating the blank slots. So if the blank slots is greater than 0, then we are looping again on a range starting from 0 to blank slots, and I'm again creating a square like I created here, exactly similar, and I'm creating a text, but this time with empty string because I want these squares to stay blank. And then I'm creating a group from this square and text and adding it to the array. Then I am saying that arrange all the elements of this ARRV group in the right direction with no gap. The buff is equal to 0 is important because we see that there is no gap between the subsequent squares. So this will give us the array, and then we are returning it, and this is being assigned to self.arr. Coming forward in the constructor, okay, before that, pointer, as we've already seen, pointer text. Okay, so we've had a look at what pointer is, which is the triangle, and pointer text is what you see at the bottom right of the screen. Next available slots index is 0. So initially it is going to be 0. The value, so this is the value, next available slots index concatenated with the string idx. Index was starting with 0. So that's how initially it's going to appear as 0. Color is red and scale is 0.5. And this is the resize indicator. So we'll have a look at this when we first encounter this. So yeah, so these are the elements that are global in this class. Now this is the construct method, which contains all the main logic of the sequence of things happening. So first of all, I'm creating a heading which is of type text, dynamic array, color is blue, scale is 1.5. I'm making it a little bit larger, and then I'm moving to the top edge, like using this method dot to edge and up. So that's why you see dynamic array blue 1.5 times the normal size, and it is aligned with the top edge. And then I'm adding it to the view, that's fine. Then I'm saying self.array move to 0, negative 1.5, 0. By default, the array would have appeared centered around the origin, that is somewhere here, but I want it to appear a little bit lower on the screen. So I'm giving it 3 coordinates, x, y, and z coordinate. X coordinate I'm not touching because the x axis, like, it is still in the center if we consider the horizontal axis, but vertically it is lower from origin by a distance of 1.5 units. And then since we are dealing with only 2D objects, 2D scene for now, the z coordinate is 0. Initially I'm going to fade it in. So if we have a look from the beginning, you'll see it fading in. First this fades in, then I am saying self.pointer dot next to this. Okay, so the pointer that I created, that is the red one, I am moving it where? I'm moving it next to the current index of array. So okay, so this is initially 0. So when you say array of 0, we get the first square and the first text, we get the V group. Then I'm saying out of this V group, get the first element, that is the square. So we get this first square, and I am moving the pointer right below this first square of the array by giving it this down parameter, and then I'm adding it to the view. So the pointer appears below the first square of the array. Then I'm saying the pointer text. I'm moving the pointer text to the bottom right, that is down right. So earlier we used uh, to edge. Similarly, we have a corner, like to corner method. So that's why we see it in the bottom right corner. And yeah, so then I am relying on a method. So what I'm doing essentially after all these things appear is adding a value to the array. So I first make the 6 appear and then bring it at its available index. So that all is handled within this method. So we'll have a look at the implementation of this one. First of all, I am getting the new value. New value is again an M object of type text. I'm again relying on this get new value method. This will take in what value you want. What is the initial position of the value? I am actually not using this parameter anywhere. This is an optional parameter, and I'm not passing explicit value for this. So -5 plus 1.5 and 0, that is -5, like 5 steps towards the left and 1.5 steps above the origin. So that will be the starting position of the new value. So if we have a look, yeah, so this is the position which I have defined by using this array. So I am again waiting for a second. You can experiment with weights yourself, and the new value would be text, and the value of this text time object will be whatever value we are passing in. Color will be green, any color you can choose. And initially I'm keeping it a little bit larger, so this is twice the normal size, and I am moving it to the initial position which we've already seen. Then I am saying add it to the scene. The value appears here. Then I'm again waiting for 1 second, and then I'm just returning this M object. So we wait after this value appears, and then the control goes back to the add element without resizing method. So now we have hold of the new value that we can see here on the screen. The next task is to move this value to the next available slot and also shrink it down so that it can fit the square. So we are again relying on this add to array method. We're passing the new value M object here. Let's see what this method is doing. So it does, it first of all plays an animation. Value.animate, scale is 0.4 and dot move to the next available index. Okay, so get the V group at the next available index and get the first element of that V group. And if you remember from this create array method, the V group that represents the square and text combined, the 0th element of that V group is the square itself. So we are saying that scale down the new value by a factor of 0.4, and then move it to the next available slot's square. So there are essentially 2 animations, and we are passing them to play, so both the animations are being played simultaneously. So the character shrinks and moves to the next available slot at same time, like this. Once that we have added it, we need to remove it from the scene. It was causing a little bit of issue if we are not removing it. Later in the video, you'll see that I'm shifting the array up when I'm resizing it. So if I'm not removing it from the scene, the array would shift with the value, but the value it would again stay here. Essentially, there were 2 copies getting generated. One is the new value that we added, and if you notice from line number 97, we are saying that we are also assigning the value to the V group of the array at the given index. So we end up with 2 copies. So that's why we have to remove the original one. And in line number 97, we are saying that make it a part of the array. So that is what add to array does. Now once we've added a value to the array, we do one more thing. Let's see from the video first. So we add 2. The next job is to move the pointer to the next square and also change this text. So there are 2 animations going on and I'm playing both of them simultaneously. So I'm saying self.pointer, which is the red triangle which we need to move, animate it and put it next to the available index. So if you look, the index has not yet been incremented. It is getting incremented at line number 22. Because it is not getting incremented, this will point to the square under which the pointer already is. So in the next 2 parameter, first of all, we need to put it below the square. So that's why we've given down here. But we also need to make the pointer point to the next square, not the current one. So that's why we are saying 1.3 times right. I experimented with this vector 1.1, 1.2, 1.3. 1 point seemed to be the most ideal. So this is what 1.3 looks like. It's still not perfectly aligned with the center of the square, but it does the job. And the second animation is we need to transform this object, this text. So what I am saying here is transform the pointer to a new text type mObject with the updated value. And I'll again have to specify the color and the scale and the position of the new text into which we want to transform. And after doing all this, I'm incrementing the index. So this completes the addition of an element to the array. Now once we've added 4 elements, we are waiting for 1 second. That again is like my choice. You can get rid of the weight or put some other weight. So element 9 is added, the pointer is moved forward, and now we are waiting for 1 second. And then I am saying remove the pointer, because now I'll have to resize the array to add the new value. So I'm removing the pointer from the view, then I'll resize, add the value, and then bring the pointer again. So yeah, so I'm removing it and then I'm making a call to resize and add method. Going to the definition of this method, here we are getting the new value in the similar fashion because that's what we need. Then we are waiting. Then we are fading in the resize indicator. This is again a visual cue for better understanding. For example, not for example, but you'll see here in this video, this banner that you see, it first fades in and then fades out. So this is what this is doing. And then I am making a call to the resize array, which does the heavy lifting of moving the array up. First of all, it moves the array up, then it creates a blank array with double size, then it copies the element, and then it removes the old array. We'll first have a look here. Moved up, created a new array, copying the values, and then deleted the old array. So it's doing the resize operation in 4 steps. This is very normal animate shift up 3, very normal animation that we're making use of. Then creating the blank array. So again, we are going to rely on the create array method. Initially it will be blank because we want to demonstrate the copying process, but this time the number of blank slots will be twice the number of slots that we have in the array, because we want to double the length of the new array. That's why a factor of 2 here. And I am creating it at, I think I don't need this dot, but let's keep it for now. Yeah, so I'm creating the new array here, which is 1 step below the origin. So that's why this -1 for y-axis. And then I'm adding it to the scene. For copying the elements, we have to loop over the original array. I'm getting the index, and group is the group of text and square. So, and then I am playing an animation that is from this group the M object at index 1, which is the text, because at index 0 we saw that it was the square and at index 1 was the text. So I'm saying that the text should be moved to the new array's index. If you're copying the second element, the index will be 1. So move it to the proper slot in the new array, and it should be run in 0.5 seconds. And then I'm saying new array of I of 1 is equal to group of 1. So essentially the new array of I will give us give us a V group, and at the 0th index of this group we already have a square because we created a blank array. But at first index we need to put the text. So group of 1, which was the text of the existing array which we animated and moved it to the new array, the same text we are assigning to this. So now this text will become a part of the new array, and then we are continuing with the loop. So that's why each of the elements will be copied one after the other, first 6, 8, 2 and 9. Once the elements are copied, then we need to get rid of the old array, and then we set the new array that we created to the self.array. So now whenever anything in this class will try to access self.array, they will essentially be dealing with the new resized array. So coming back, once the array is resized, we need to bring the pointer on the view again. If you can see, we copied the values and then we made the pointer appear, but we cannot make it appear at its original position. So first we are moving the pointer again to the appropriate position, that is whatever is the next available slot, move it below that and then add the pointer, like make it visible. And then we are saying, so the new value we have to again add it to the array so that it persists. And then we are playing this animation, which is a combination of two animations, not one, which is yeah, these animations we've already had a look at. The first one makes the pointer move towards the right, and the second animation updates the text, bottom right text. And then we are waiting, then we are incrementing the index, and that is what the resize and add does. Then we can again add 3 elements. So after 11 I am adding 3 more elements, that is 23, 19 and 7, which are being added from here, 23, 19 and 7. Then I'll repeat the same process again because this is the time to resize. Wait for a second, and actually here I'm not waiting, but that's fine. So we need to remove the pointer, and then we need to add a new value by resizing the array, which we've already had a look at, and then we are adding some more values, and then at the end waiting. So we will increase the speed, and we'll watch the video once again from the very beginning. I'll increase the speed a bit more. So it's resizing. And then it will resize again. So that is all for this video. If you have any doubts, please let me know in comment section, and thanks for watching.